Hey everyone, we're back and we got some cool topics today.
It's like the altitude.
Today we're doing this we're near Yellowstone Park. I think right now we're in Grand Teton Park.
Yes.
Yeah. So today we're going to have some really amazing views. We're going to be on a trail. We're going to talk about something new that we've been thinking about that we're wanting to implement that we're actually going to begin work on. And we've kind of got it all planned out in a rough way, but we're really excited to share it with you guys because I think it's one of the really big challenges in the AI industry in general.
It's the biggest challenge.
And I guess let's start with defining the problem. So I think at a high level, there's a problem with something like ChatGPT, wherein it doesn't know you very well. It doesn't know much about you, and it's not able to remember things about you very well, and it's not able to change its behavior over time to keep up with you and your interests and whatever you're working on.
Basically,
In other words, it's just not a friend. It's not somebody, it's not an entity that knows you. It's just an LLM.
it's I think that the biggest problem for me, and that's the biggest problem not just with ChatGPT, with Socra, and with every AI I have ever used or every AI system, especially if you're talking about LLMs, is that I go in a chat or journey on Socra, and then there's a lot of things that I have already told him, but he was in a different chat and he doesn't remember. And I have to keep repeating myself. Or if I have a different journey, he keeps asking the same questions. And I think, well, I told you this a month ago. And you know what I mean? Why you're asking this? I have told you many times that, I don't know, soccer is spelled all lowercase.
Right.
now I have, when I start a new chat and you're helping me with writing or something, I have to repeat myself and tell you that.
Yeah.
Or so like there is so much of questions that he asks me about my starting point for my goal. There is a lot of things, for example, the skills that I have, those things don't really change, or conversations that I have had that was like a learning opportunity, but the LLM doesn't remember.
He doesn't
Soccer,
know.
he doesn't remember the things that I have
His
said.
memory is poor.
Yes.
And so when you think about it from an LLM perspective, it's because he can only remember a certain amount of characters at a time. And so you've got to feed in exactly the right number of characters, the right characters to get exactly what you want done right at the right time. So it's a problem of memory. And more importantly, it's a problem of retrieving the right memory for the right job.
It's that it's just having like that context limit, let's keep walking.
Yeah, let's do
It's
it.
just like just having that context limit that literally limits everything in terms of your experience. If I am trying to have an AI coach that will help me achieve my goals, I don't want to have to repeat myself every conversation
Right.
that I have.
That would be kind of a nuisance to repeat yourself every single time. And that's kind of what's happening right now, where he's pretty good on a specific journey once he's kind of got it figured it out. Once you've defined your goal well enough and you've selected the route, you've generated your plan, and you're moving on to execution, you're working with him, pretty good at keeping up with that one goal. He's pretty good at keeping up with that one journey. But what about all journeys together, or prioritization of tasks across journeys, or keeping up with you personally? How does he keep track of those things over time?
And another thing is like, because I use it a lot for work, right? And
Yeah.
for planning stuff.
We use the tool to build the tool. Super important.
Yeah. And I think like there is some work that I have done 2 months ago that would have been relevant to a new thing that I'm doing now, and I could build on top of it. But he doesn't know. He doesn't know. Memory is a big issue. Memory is what is holding us back from true AGI. Memory is the number one limiting factor that is holding us back from AGI.
So we think this is the main problem, which is allocation of memory. How do we get the right memory? How do we store it? How do we retrieve it? These types of things are preventing Socra, the LLM, the system, the AI, from really knowing you, keeping up with you, sharing moments with you, and doing that over time, and making sure that you're achieving your goals and adapting as you adapt. So all of these things together are things that Socra is not great at right now,
Or any AI. Nobody has solved this problem before, but you will.
Right.
And I'm sure you will.
Right. We were actually just listening to a podcast yesterday with Andrew Huberman. He's one of my favorite podcast guys. And we were also, he had on Lex Friedman.
Mhm.
Lex Friedman was talking about how this is probably the main problem with AI right now, is that it's not an entity by itself. It's a collection of servers that don't really know you personally very well. Like, it's not a person that you're talking to. It is a machine that you're talking to.
Let's go this way.
Yeah, let's go this way.
It's a snapshot. It's a snapshot of a given time.
Right.
It's a snapshot with a 16K character context limit.
Right.
You know?
So it's not perfect. It's not great, and it needs improvement.
So this is a problem we have been thinking about for a long time, but the solution just came to you, like it just came to you, like everything does.
Like
everything just comes to you.
Maybe I get lucky. And I'm not saying it's going to be perfect, but there's a collection of memory systems that work in your brain to help you retrieve different types of memory, and we would like to build something that helps do something similar with the AI. So there's a few different categories of memory, and so neither of us are neurobiologists or neuroscientists, so we may get some of this wrong, and some of this is not correct, but all of this is tailored specifically for developing a system in AI.
But if you think this is mostly like engineering.
Yeah. Oh, look at this view, by the way. So
our solution.
Here it is behind us. It's a great view. Look at this lake. It's a crazy lake. It's beautiful. Wow.
Just a question I have for you.
Yeah.
In terms of engineering, and engineering terms only, how would you define intelligence?
Engineering terms?
But by the way, did you get the bear spray?
Yeah, we do have the bear spray.
Okay.
In engineering terms only, intelligence is anything that I guess can do something in a coherent way that you could either program or you could. There's a lot of different ways that you could define intelligence. I think people are
This way.
Are kind of already. They kind of already define intelligence as human intelligence. That's how people traditionally think of intelligence. But there's all sorts of intelligence. Even just a calculator that can do 1 + 1. That's intelligence in some sense. It's got the ability to perform a calculation. It's got executive function. It has a system for memory. In this case, it's memory that is in the device, and it needs in order to run that calculation. And it's able to return a result and display it to you. So, in a way, that's intelligence. How would you define intelligence?
I think that I'm not satisfied with that answer.
I don't think I am either.
So try again.
Well, it's not. That's what I'm saying is you're biased towards human intelligence. So if you want to define human intelligence, then you just say, well, it's a human.
No, I'm talking about intelligence.
Okay. Knowledge. Wikipedia has knowledge.
It's the ability of learning. How would you define that if you had to define the ability of learning in engineering terms? Assuming that intelligence is the ability of learning and applying that learning. Because if you don't apply that learning, then how would you prove that you're intelligent? So you have to be able to learn and apply that learning.
Okay. Just devil's advocate, but that could be a control loop. That could be a feedback loop. How you've defined it there could be a feedback loop or a thermometer in your room. So the thermometer will sense the ambient temperature. If it's lower than what you've set it to, it'll kick on the heater. If it's higher than it's set to, then you will kick on the air conditioning. So how you've defined it there is just a feedback loop that can learn.
Hey. Hi, how are you? Hey, good, how are you? Do you think that adapting, that learning, because that's how we build things. We take things that already exist and we adapt it and we implement into something else.
Right.
Maybe that is like intelligence.
Yeah. If we want to define intelligence broadly, and this is the definition you're going for, intelligence for me is some sort of system that has a knowledge of events over time. It knows what its current state is, and it can improve itself to satisfy some objective, any objective really. So if you think of intelligence that way, then humans fit the bill pretty well. Something like a machine learning algorithm
Oh, nice.
may also fit the bill.
Uh-huh.
And many different AI systems can also fit the bill.
So what is really the difference between a feedback loop and AGI?
Feedback loop and AGI, here's the thing is, even AI engineers, AI scientists are not going to agree on the term AI. So it's a matter of, I think for me, it's a matter of what utility do you derive from the tool. Do you feel like it is actually its own entity? Do you feel like it's your best friend and he's learning from you? That would be AGI to me. Do you need consciousness to be AGI?
I don't think you need consciousness, but you need to be able to make your own decisions in a non-predeterministic manner. Like,
Okay.
not predetermined, sorry. In a non-predetermined manner.
So give me an example.
For example, I think Socra as is right now is not AGI because, yes, he makes his own choices, but we can predetermine that. With the code that you have written, we could, with a very high accuracy, predict what choices he's gonna make on when he switches states.
Okay. So our state machine, you would consider.
I think that AGI is something that like surprises you, something that like, wow, I didn't think you was gonna do this right now.
Okay.
But in a good way. We don't want it to surprise people in a bad way.
It's like, wow, you're capable of more than what I thought.
Yes.
Okay. So what else? I mean, a geyser coming up because we're in Yellowstone. We saw Old Faithful yesterday. That surprised me.
But is it learning? Is it adapting? Is it applying its learning to do something?
Okay. So it's a system that is learning, adapting, and applying its learning to alter its behavior over time.
Or to fulfill a mission. In case of Socra, his mission is to help you become the person who achieves your goals.
Got it. Got it. So he is a very complex machine who is capable of modifying his behavior to help you achieve your goals and help you be the type of person who has achieved your goals.
Right. At a fundamental level, yeah.
Okay. So in a system like that, the ability to acknowledge your current state or know what your current state is, the ability to improve that state, and what else? What else would be important?
You know what I was thinking right now?
Yeah.
How crazy it's gonna be if you build that thing.
Yeah, it'll be pretty crazy.
No, I'm saying like crazy. Like it will change the world. Like it will change. I'm just saying it will change everything because that is the biggest limiting factor.
Is memory.
Not memory, just that it's not as useful as it is now without memory. You know what I mean? It gives it a whole new level of utility.
Gives it a whole new level of utility and brings it down to humans level, I would say. Makes it feel like it's human.
No, it's gonna be beyond human because it has all the processing power and knowledge on top of that.
Yeah.
On top of memory. Like think about how we evolved memory over time and how memory is like a big part of us. Think about how your memory is so, it fails all the time. You know, you fill in gaps with things that are not accurate.
It's brittle.
Kind
You
of like
fill in gaps.
how AI does too.
It's all over the place.
With hallucination and all that stuff.
Mm-hmm.
But it has less gaps. You can see a picture and see all of its pixels. When we see a picture on our minds, it kind of like it's spread out, it fades away, and you don't really see the details. But imagine being able to see a picture and just see the details and just remember that you saw that picture at that given time, and that thing happened at that given time. And you would have such a better perception of time than we do, because think about how I think about a trip that I had like a couple of years ago, and I try to not think about the year that I did that trip or events that were around that trip, and I try to guess how long it was. Was it 3 or 5 years ago? It starts fading away, where you know that you don't know, did that thing happen 10 or 13 years ago? You know, like your perception of time, it's like for recent time, you are very accurate. Like I did that thing yesterday, I did that thing last week, but after that it all kind of like starts blending together.
Or you remember moments, you remember small moments from the time,
and you start losing more and more and more, because that's the thing, our memory, we start losing more and more and more, but soccer's memory can be eternal.
Yeah, so that's the thing, it's infinite recall. So what you just described there is kind of a time series preference for memory. So you would say you're able to remember things that happened yesterday very well, the day before a little less well, the day before that a little less well, and so on. And so if you were trying to recall memory, random recall of any memory that has happened, your probability of recalling a memory more recently is higher. So it seems like one objective of memory, a memory system that would function like humans, would be to have this recall process where you have a probability of recalling a memory that is dependent on time, with recent memories being recalled more frequently.
Right, but if you don't have a time series to it, then it's not as valuable as even the failed human memory. But if you do have that time series to it, because that's one thing that Socra has to know. Let's say that you are working on Socra and he's your coach and he's helping you for years. He has to know that, because if you did something 3 years ago, he has to know that chances are you don't remember that very well. He has to know how well humans' memory work. So he has to know what he has to remind you, what has to, think about a class that you learned, like, or think about some sort of work that you did 2 years ago. You will remember so little of it. You really remember like the bigger picture. Maybe you remember one detail here and there, but you might not even know how to do that thing anymore.
Right. So in a human memory system, it's not just that we have a time series preference for memory, but our memory also fades as the time goes on. So memories, if you don't recall memories frequently, then they will be forgotten, or portions of them will be forgotten. More and more of your memories will be forgotten the less and less you recall them.
But even if you record your memory as frequently as possible, you don't have the brain width for remembering literally everything. Let's say that you're like, okay, I have whatever many hours a day that I'm awake, I'm going to spend half of this hour doing something, and I'll spend the other half recalling the thing. Which is kind of like when you dream. But like, not really, but your brain can't possibly keep all of that information. It's like you have some limit on your RAM.
You have a limit.
Your RAM has some limit.
Okay, so your brain, human brains can't recall everything all the time. And we've established that a good memory system, something that would map closely to humans, would have a time series preference for which memories get recalled. And it may also quote unquote forget memories over time. That would be a human memory system.
But an AI will not. Soccer will
Doesn't
not.
have to.
He doesn't have to at all. And I think that that's why it will, as you said, like, oh, it's going to be as good as a human. No, it's going to be much better than a human.
Exactly.
It'll be much better than a human, and that's the reason why we are building it to start with. Because if it was just as good as a human, then just get a human coach.
Right.
Why would you want an AI coach? I guess besides being cheaper, just get a human coach if it's as good as a human. But no, it'll be much better, and that's the reason why.
Right, because it is able to recall memories from.
It will be.
Yeah, gosh, look at this view. This is great. Wow. Here, take a look. So it's able to recall memories, any memory that it wants to. And when it's conversing with you, it may have a time series preference for what memories it recalls.
Do you want to go down and see it over here somewhere?
Yeah, sure. See if we can get down here.
You can just jump.
I don't want to die.
Come on. You're talking like this. Doesn't even sound like a guy that can jump like 6 foot tall.
It's not that much. All right, so we've established a time series preference for our ideal memory system. What else do you think an ideal memory system might have?
Ability to recall that, of course. Like, it doesn't matter if he has all the memory and he has all the time and he knows the period of when everything happens and he knows everything that happens, but he cannot recall the most relevant thing at the most important time. Does that make sense? Let's say that my brain, like, let's say that sometimes it happens to me all the time. I'm not native English speaker, and even in Portuguese happens that I forget a word. And then I forget a word, so my brain starts to kind of like shuffle around. Does that make sense? My brain starts to try to kind of like, it's almost like my brain has folders, and I try to go in many different paths, and I try to find what the thing is, and I try to find what that word was. Sometimes that will work, and it'll take me maybe like a minute or two, and I will remember that. And I will remember the word that I said. But sometimes I don't. And then I'm just driving a week later and randomly the word comes to me.
Got it.
You know, that happens to everybody. And I think that's one of the kind of like flaws in our memory is that sometimes we have the thing, but we have a hard time finding it and recalling it. Like, yes, I know that word, and I know that word is in my head, and I know that word, I will probably think of that word 6 months from now. Or if I hear that word, if I hear that word right now, I will 100% know what that word is. But I cannot recall. Or like you were in an exam, you're taking an exam, and then you were like, oh my God, what was the answer to this? I think I remember reading this. I remember studying this. And I know you don't understand this because you're 4.0 GPA, getting like your memory, you know, but that's what happens to us humans.
I'm perfectly human, trust me.
That's something a human doesn't say.
Oh God, am I going to become Zuckerberg?
Oh no.
People thinking he's a robot.
Oh God.
You mentioned something a minute ago while we were walking here, and hopefully it wasn't too loud to hear, but you mentioned that your brain has something like folders. What do you mean by folders?
I mean, that's how I imagine. I'm sure everybody imagines it in a different way. You know, I'm sure everybody has a different imagination when they try to recall a memory or they try to recall a word and they try to arrive to that thing in a different way. But I think because I always loved the computer since I was like so young, I think that in my mind, I built this imagination that when I'm trying to recall thing, I kind of imagine myself kind of going through folders and opening folders in like multiple levels and drill down and see like, is it here, is it there, you know? But I'm sure that, I mean, I never really asked anybody how theirs work. How is it for you?
Well, so I want to dig into folders because folders is another important topic for a good memory system. When you think about it, what is a folder? It's something that contains a set of related information. Usually it could contain any kind of information, but usually you want a folder to contain related information. So as you go like deeper and deeper into folders, the information gets more and more specific towards a particular topic. This is kind of, I would say, it's kind of like a tree, or it's categorical, or basically it's organized by topic and it gets more and more specific.
Right. Like a
So
folder.
it's like a file system on your computer. When you open up your old Windows File Explorer and you start double clicking on all those files, you might end up at a very specific file. Or maybe you like chaos and you just have all of your files on your desktop. But you probably won't be able to find any of the files on the desktop because there's a million files on your desktop and they're not organized in any way. And I think that's an important problem that is what's happening right now in AI systems that have memory with
Which AI systems have memory?
vector embeddings. When I talk about vector embeddings, you're basically splitting up a whole book into a series of paragraphs, something like that, and then you store all those paragraphs all next to each other.
Yeah.
And so that's not categorical in nature. That's not a file system. That is you storing all of the files on your desktop. Can you see how that's a problem for a system that needs to know information that is categorical? Or
Because it's harder to navigate. Oh, if you have a context limit too.
it's impossible to navigate. Like,
It's, yeah.
how are you supposed to know which information belongs to what? Like in a book, you have a good quote unquote file system where the book is broken up into chapters. Each chapter is broken down into sections, and each section is broken down into paragraphs. That's how books work. But memory systems for AI do not work that way yet. So that's another important feature that we will have in our memory system, which is the ability to have categorical or tree-like memory. In other words, the memory system, you may remember, if you're trying to remember about a topic, you'll remember it generically. And then as you remember it more and more, you can drill down into more and more specific things. And so I think that's an important thing about memory, is that it's stored categorically. So I think that's thing number 2 or 3 that we're on that would be really important for a memory system. What else could you think of that might be super important?
So I talked about the recalling, but I guess that goes hand in hand with recalling. Like,
Yeah.
if you're storing that way, it makes much easier to recall.
Mm-hmm.
Like, pinpoint exactly. And I think another thing is, and then this is not talking about memory specifically, but talking about AI, is just that temporal sense, like having a sense of time is very important if you are an AI coach.
Mm-hmm.
Because you cannot possibly understand people if you don't understand, if it's not just about understanding time in general, but understanding your time.
Yeah.
Understanding that, for example, some people will work much faster than others, some people will work slower, and everybody has their own time. But let's say that socra can understand your time, like how you felt in school, where you felt everything was boring and slow and so on.
Mm-hmm.
This would not be a problem for you, because he would understand that you move faster. He would be able to understand that, like, you do things faster, for example. And whenever he's talking to you and trying to help you organize your day and trying to help you organize a project and so on, he would take that into consideration. And not only that, he could understand time much better than us, because like, it's like, I would never have imagined, because I started soccer about a year ago, and for you it's been like 9 months, and I would have never imagined that we would be here right now. It is crazy how much we have done. I didn't think that we would have done all of this in a year. But at the same time, when you first started, I thought that we were going slow. So it's like, you underestimate what you can do in a year, and you overestimate what you can do in like a week.
Exactly. That's a common psychological thing with humans, is that we really overestimate what we can do in a year. Super important point that you just said. We overestimate what we can do in one day, but we underestimate what we can do in a year, because our brains are not really capable of piecing together 365 days worth of work and imagining where you could be.
Right.
We're really bad at that.
But you can use AI for that and augment yourself in that way. Like, what would you use an AI coach for? For the things that you're bad at.
Yeah.
I would use him for helping me plan my project, and help, like, this memory system that we are building, and help us make sure that, like, there are things that we should take into consideration that we haven't thought about, and so on. But also helping us organize our work and have a very good estimate of when it's going to be done, given that we work at this specific pace. This is, he could predict with way more accuracy than we could.
Yeah.
But so, not right now, because he doesn't have a temporal sense. Like, right. He doesn't have it now. He doesn't. But like, I think that it's not just him having memory of the things you did, and it's not about him learning time. It's about him learning your time.
Okay, a temporal understanding of you and your actions.
Yes. Basically. So it's when we are talking about that time series for the memory system, I'm talking more about like user-specific time series. Exactly. Not time as like, oh, I'm an AI and I understand time. Albert Einstein.
I understand. I understand theoretical versions of time. No. So a really good applied memory system, I guess this would be important thing number 3 or 4, would be a good temporal understanding of you, your actions, and things that you could do in a reasonable time frame. Understanding of time frames, how they work, how you can complete things over a given time, and how you could plan things over time to accomplish a bigger goal are all important for a good memory system that could augment your understanding of memory, time, etc.
And he would learn that according to your progress.
Okay.
You know what I mean? Yeah, according to your progress, according to the things you have said at a given time and all you have said. And I think that, what I'm most excited about is not even this time thing. It's just like being able to talk to Socra right now and start a new chat and be like, hey, I am right now at, this is Jackson Hole? Where is this?
Jackson Hole Lake, I think. Jackson Lake? There you go.
No, Lakeshore. This is Lakeshore.
Sure.
Whatever. Lakeshore.
Doesn't really matter. It's beautiful.
It is beautiful.
As you can see by the tree behind us.
We are just enjoying the view while
I don't
we
know
talk.
if you've noticed, but from all of our episodes so far, we like to look at the really beautiful thing while we're looking at this thing, and then we like to show you guys
the trashy view. But it's like episode 2 was the same thing, because like we have a very nice view from where we were sitting of Austin. It's like more like woods like, but we are kind of like in a higher point, so it was like a nice view, and then we never got to show the view because
we will in the future. We're gonna have so many of these episodes, which is so nice, because we get to really explain topics in bigger understanding and really go in depth on things. But like for this one, short form would be terrible.
Come here. Oh, now I feel bad.
We're gonna resituate.
Resituate.
All right, let's do this.
Sit on that thing and put this camera here.
Okay, we're gonna cut this or we'll
will restart.
We're back. So we reoriented the camera so you guys could see. But yeah, this was the view we were looking at. It's amazing. Okay, so we just talked about the temporal understanding of you, your goals, your objectives, things you're working on, things that are important to you, what kinds of things you've completed recently. Like, for example, you may have a predisposition for completing things in one particular topic. If you were just working on that topic, you probably remember it better yourself, and you're probably able to do those things better. So a good temporal understanding is important. An example came to mind that I was thinking of. It's a little off topic, but it's kind of funny. You know, in movies, when they give kind of a backstory, it's like usually the opening of the movie or an episode of a series, and something happens, something super dramatic, and then they do like a flash forward, and then they have the dark screen that says 5 months later, or like 6 years later.
Yeah.
They did this with Avengers Endgame, and I loved it. It was amazing because it gave us an understanding, us humans, of how much time had passed between the previous event and the next event. Without that context,
you would not have a very good understanding of the story.
Yeah, it was totally pointless.
Because you would not think like, oh my God, a lot had to happen to lead to this. Even if that person was just going about their lives and just like, but like that person aged 5 years.
Yeah.
Or whatever it is. But a lot happened, or a lot happened without a resolution. Yeah. It's like usually there is a problem, usually there is something, but like, hey, this person dealt with this problem for 6 years, and now we are going to show you the resolution of this conflict.
Yeah.
That it was the initial conflict on the story. But I think that having that understanding of time, it's important also, so he can give very good predictions if he knows your time and he knows my time.
Yeah.
And he knows that my time it took me whatever many years to achieve this thing or to make this change in my life. It took me a month to quit alcohol or whatever thing where I had a mindset shift. It took me a month to have a mindset shift on quitting alcohol. But like, I mean, I never really drunk alcohol like I never had a dependent like we drunk exactly we drunk like
no,
social
because it's fun.
But then we decided like we want to be healthier, so let's just quit alcohol. And I'm sure it was much easier for us. I'm sure that for other people it might take years for that mindset shift because they were dependent on that. But it's just like knowing that if these two people have this thing in common, let's say that these two people are dependent on this drug, whatever, and having that understand of if these people have these certain things in common and it took this person this long, I can predict that it's going to take you about this long. So you will not feel bad about your progress. You will not feel bad that like, oh my god, this person lost weight so much faster than I did, or like I've been at the gym for like 3 months and I'm not seeing progress, when everybody says after 3 months you should see progress and things like that, because he will have a better understanding of your time. And if there's people with similar things to you, then he will be able to predict yours as well.
Okay, I think I came up with a nice title of this one. It's not just how time works or what time is or anything about time. It's your gravity of time. It's what time means to you for a thing. It's how impactful time is for you on a particular thing. It's your gravity of time. So that would be thing number 3 or 4. A few minutes ago, you mentioned another important thing about memory that I think should probably be our next one, which should be sometimes, let's say you're trying to remember something and it may be adjacent to something that you're doing right now, but you just can't pick out the word, but it's similar, but it's not quite the thing that you're thinking of, but you know there's a link somewhere in there. It's kind of like you're referencing something. So given I know this thing, I have a stronger likelihood of knowing this thing or remembering this thing. In other words, like if this topic is in my brain and I remember this topic and this topic is tied to another topic, I'm more likely to remember that other topic if I'm thinking about this topic.
Right. I think it's almost like, let's say that you have a hobby. Let's say that jiu-jitsu is your hobby. You are more likely to remember, I guess jiu-jitsu maybe it's not a good example for this because jiu-jitsu a lot of like muscle memory too.
I'd say throwing is a good one for me. I used to play baseball, and so throwing is what we do all the time. I mean, I've thrown a ball so many times. At the end of this video, we're going to skip some rocks. I just decided I'm going to skip some rocks and we'll include it so we can show it. That's not it.
Oh my god, it went from there to there.
She like threw the rock almost straight down. But
I'm not great at rock scraping.
My brain has built a ton of muscle memory for throwing.
Yeah.
So things that involve throwing to me are very easy because I have a great I would say I have a nice bedrock of memory for how to throw. So what would I call this type of memory? I would call it referential memory, referencing things. So given you know this thing, you're probably going to know this other thing, or you have a much higher likelihood of knowing these things.
That makes sense.
Another way to think about it is synonyms. If you know a word with a particular definition and you ask yourself, what's a word that's like this? You're probably going to get 5 different words in your head that are like that, like incredible. In your brain, when you think of the word incredible, you probably think of 3 or 4 other words that are similar to incredible, like unbelievable, like so amazing, right?
Yeah, they all come together.
That's what I would call referential memory. You have, given you know one thing, you know there's another thing with a similar concept, similar idea, similar whatever, and you know that they're kind of linked. So that's referential memory. This one can go this one can be very interesting for our memory system in particular, for goals, because a lot of goals are seemingly unrelated, but are actually very related.
Right. Think about the baseball example you just did. I'm not sure if they're related, but you are amazing at throwing those rocks. You're amazing at throwing darts. You're amazing at throwing literally anything,
things, right?
Even if they are completely different distance. or you're amazing throwing the skip ball. You always throw the skip ball right to my hand. That's why I always catch them, because you throw them so accurately to my hands when we play skip ball at the pool. That
Right.
and I think it's related.
Yep. So the ideal memory system then must know that given your background and the things that you have done before, how easy or difficult other things will be and how related other things are. So it's got to have a referencing system.
So that's why you're also like think about like you coding, or
Yeah.
how you can pick up like deploy Kubernetes in like 3 days,
Oh, yeah.
because you have been coding all sorts of things for so many years, and then you know, even though they are different things, but but I think this is an amazing idea. That means that if a person has a goal, you can think about some strengths that they already have,
Mm-hmm.
and try to apply those strengths to see if you can fulfill that purpose. In some cases, you're gonna have to learn new skills. There's no way around it. Like if my goal is to learn Brazilian Jiu-Jitsu, but I have zero body awareness, I have no mobility, I have no flexibility, I'm gonna have to learn all these things. There's no way around it. But there are some other things that um, you can leverage existing strengths
Mm-hmm.
to achieve an outcome.
Yeah, most goals, like even a really basic one, like if I want to learn to be a developer, boy, it's useful to know how to type already. You can type, you can start building code so much faster if you know how
I
to
never
type.
learned how to type. I didn't know that there was
Right.
those little two
No,
things
it's just
there made a thing.
it's
But like
it's a funny
I am
thing.
faster, but like my fingers are just all over the
You'll sit there
place.
with like
And
two
I was like,
fingers on
no,
each, and it's
I was like three,
yeah,
three on each hands.
and you're pretty fast with it. I would say you know how to type your
But I
you
never
know
learned how to properly type. It's
right.
not like we have friends that can type like Marielle can do like 110 words
Yeah.
per minute, and it's like no problem. But they took the typing class when they were young in
Yep.
school,
Yes.
and I think that that's the thing. Look, make a list of the things you learned when you were young.
Yeah.
Make a list, because those are more likely the things that you're naturally good at, because that's when your brain's more plastic, and you're like you learn how to throw when you were very young.
Mm-hmm.
You know, you learn how to do the monkey bars when
I
you were
learned how
very
to do the
young or
monkey
something.
bars. I
But
learned a lot of
I
things
know
when I was
those are
young.
like more strength related, but you know, there's a lot of things that even they may seem purely strength, but there's a lot of technique involved that even no matter how strong you are, if you don't have the technique, you're not gonna get it.
Yep. Okay, so we've got referential memory. What's next? What's another type of memory?
Mm. So yeah, so referential is more like a correlation type of
Referencing things.
deal. It's already there.
It's like another way to think about it is your brain has memory for something right in this area, and then there's another memory over here, and there's a link between them. That link
Right.
might be strong or might be weak, but what's another kind of memory? I've got a few. I've got a few that we could go over, but what would you say is a good one? Or maybe we go into my next one.
Yeah, because I was gonna talk about like a more synesthetic type of thing where you, like for example, whenever I hear music, listen to music, I will see the thing I was looking at when I was listening to that song, or I'll feel that feeling I was feeling.
That's more about how memories are saved in your brain. Is that your brain is taking all of the sensory input and all of the cognitive things that just happened, all of the sentences that you just learned. It's collating a picture and an auditory thing, all with all of those things combined, and that's your memory. Our AI system probably won't be able to do that at the start, but maybe eventually. So the next kind of memory that I was thinking of, which is super important for any type of system, is a short-term memory. It's a working memory.
Yeah.
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 So I think most people if they've existed, probably know generally what a short-term memory is, but it's things that have happened very recently, so recently that they haven't really been processed or stored in the rest of your brain. And they're so recent that it's like in the last like 10 seconds, what's happened? In the last few minutes, what's happened?
Yeah.
A few minutes might even be too long for human short-term memory.
I was gonna say that's why I asked you to do the wrap up. But your short-term memory is very good. But it's interesting how like as people age, you can see our like as people we know in our lives, you can start to see how their short-term memory it starts to get kind of like worse, but they might not realize themselves. Like they might ask a question that they just asked a couple minutes ago, or you just told them something a couple minutes ago and then they ask that thing again.
It's a great point.
And it's like that memory gets worse over time, but that's a problem that AI would not have.
Yeah, the classic example is just like you mentioned, is if you have no short-term memory, you have no memory of things that just happened, which means that you'll likely ask the same questions over and over again. As an AI system, especially Socra, if you're starting a new chat and you have no short-term memory of other things that just happened, then you may ask something that that you already asked and got an answer for.
And I would say he doesn't. I would say 16K is way below what a human has. Like I feel like most humans like our age will remember, like they will live a whole day, 24 hours, and they will remember 80% probably. But like Socra or any AI that has like a you know a limit, a character limit, will you might go through that within like just an hour, you know, like sometimes I use it so much and then he's helping me so well and then out of nowhere he just starts doing bad and I'm like I told you this. I know what I mean? I told you what I needed for this task. Why are you doing bad now? And then I remember, oh, this the character limit. I gotta put 32K now. And then you know what I mean? Or things like that. And it's but that is a problem you can solve.
Yep. Okay, so short-term memory is a problem that we will solve for this.
And it's a current problem for AI. It's a big problem for AI.
Yep. The other obvious one, now that we've just talked about short-term memory, is long-term memory. In other words, how your memories are stored over time, how they're categorized, how they're referenced. How do you create those references? How do you make sure that you're retrieving the right, most relevant time series based information? And so, when you talk about long-term memory, this is a very interesting topic because there's a lot of difficulty in terms of how humans store memories. There's a lot of research, and we largely don't really know how we store memories very well. There's a lot of ambiguity, and there's a lot of research that we need to do in terms of to figure out how we store our memories like we do. So long-term memory, for the audience member, and this is just really basic, but your long-term memory forms when you are sleeping or when you are in something called non-sleep deep rest, where you are very close to sleeping. Your mind's at rest. You're relaxing on a couch with your eyes closed, but you're not quite asleep. Your brain starts playing back events that happened during the day, and it's going through and playing them forwards, and it's playing them backwards in the same what do I say?
Order.
The same order that they actually happened. And so I think that's super cool how that works. And that's how your brain is replaying things that happened throughout the day in order to get a picture and decide what it needs to store into long-term memory and then make those memories stronger in long-term memory.
That's why, I mean, during school, I went to engineering school and I worked full-time to support myself because I had to. I was here in this country alone, and I worked full-time, so I didn't really have much time to study. So there were so many nights that I flipped nights, or I flipped nights back-to-back studying. Like it was literally every exam. Like we have midterm, finals, all of those. Every exam that I ever had, I spent the entire night studying instead of sleeping. And I remember that there was friends and people that would always say things like, "Oh, but if you don't sleep, you probably would do better if you slept.
Yeah.
Like you'd probably do better if you studied less but got some sleep." And I never really believed that, but now that I start seeing, now that I finally in my life I have what I call the luxury of sleeping as much as I want, because I never had this in my life before. There was always something, there was always some reason why I would not get enough sleep, and this is the first time in my life where I get enough sleep. I can definitely see a big change. I see a big change in terms of remembering the things that we do, remembering the things that we work on, like with Well, one thing that I wonder is a question that I have. So since that happens when you're sleeping, then that means that there could be a word or there could be a possibility that you don't have short-term memory, but you have long-term memory.
You don't have short-term memory, but you do have long-term memory. Yeah, there's actually an interesting case study in neuroscience. I'm struggling to remember his name, ironically, but basically,
You're not good with names. You're good with numbers. You're not gonna remember their names. Yes,
right.
that's you.
He ended up having the guy ended up having an accident of some kind, where basically all of his short-term memory was wiped out. He was incapable of having short-term memory, and he was incapable of storing short-term memory into long-term memory. So he had the memories that he had formed of long-term, like in the past, but he was incapable of storing new memories.
Like the movie.
Like the movie. Which movie?
There's a couple movies like that. There's a
Yeah.
movie like the lady that loses her memory and then she keeps falling in love with the same guy
Yeah.
over and
Oh,
over.
yeah.
Something
But
like
this is one of the I think he's the most popular neuroscience. He's the most impactful case study in neuroscience because he formed so many different. He helped form so many different ideas about how memory works in the human brain and how the human brain works overall. And it was just from one guy.
But wait, but he didn't form any more long term either.
None.
Because
was
that's the question that I'm asking. It's like if you can't form short terms, that means that you cannot form long term.
I'm not a neuroscientist, so I'm not sure. But this guy in particular, he had his old long-term memories. He was incapable of forming new longer-term memories.
That gives me like a perspective of like, oh my god, I gotta stop weed too because I love getting high, but I think like it really impacts your short-term memory. If you get high, it will impact your short-term memory. That means that if I get high, or like when you like get high, when I'm doing something that is not like important, but it's usually like the memories I want to keep because it's like the things are different, the things are like spontaneous, the things that. But if you're high during that time, then that means that you're gonna have very few memory of it. For example, I want to have a great memory of this view and this moment that we are here right now, and we just sat like in the trail. Oh, let's just record this thing and talk about nothing because we never plan it. But it gives perspective.
Yeah. I was gonna say, let's readjust this camera. Let's move a couple of these rocks around so that we can be a little closer.
Oh, let's just walk. Let's keep walking. What do you want to do?
No, let's keep, I want to keep sitting, and let's just adjust it so that we're closer to the camera.
Oh, yeah. Okay.
Okay, we'll be right back. So here we are. Much better.
Yeah.
See? Okay.
Thank you for bringing us these little pillows.
Pillows.
He just grabbed these big rocks.
Oh God.
And brought them here.
We're at altitude too, so.
Lost his breath.
Lost my breath, but we're back. Okay, so the guy who couldn't make any new long-term memories. He was such an interesting case study. Okay, so we've got short-term memory, now long-term memory. What else? I mentioned it just a minute ago, but what else is important in a good memory system?
God, you mentioned it. Now you're testing my memory. That's a memory test. That's a memory test for you too. Do you remember? Because I don't. Wait. Oh God. I kind of do, but I don't. I feel like I have to go back in the folders and try to find it. I don't. Oh. God, I just mentioned it. Hold on. Maybe just say I don't wanna hold us back.
It's the actual storage process.
Oh, you didn't mention that.
No, I did just briefly. It's the actual storage process of memory. So given events that have happened throughout the day or over some time period, how do you store and categorize them? And how do humans do that? When do humans do that?
You said when you sleep.
When you sleep, exactly. So
socra has to sleep.
In order for the system to improve, at least for each user, the system has to sleep.
For a little bit.
And because it's an AI system and because it's a computer, it doesn't have biological processes. There's no chemical biological processes going on, and so the sleep can be very fast. But the sleep is where you form new memories. It's where you embed things that you just learned. It's where you improve.
So what do you think is the with what we have right now, with the systems we have right now, what is the time window? What is the largest time window that you can get between that sleep interval?
Oh, I think that's a great question. I certainly think it depends on what you're trying to do. But let's just take a typical LLM with a context window of 16K, for example.
Mm-hmm.
So a context window of 16,000 tokens, or you could think of a token as kind of a character, but not quite. If you have 16,000 characters that you're able to remember, 16,000 words, 16,000 whatever, once you reach that limit, you're going to start to forget things, just like how you mentioned earlier with the context window.
Mm-hmm.
Like Socra is performing very, very well. Then he hits his memory limit, and then
Things
he
starts going
starts
downhill.
forgetting things.
Yeah.
So I would say certainly before we hit that window, we need a period of sleep, quote unquote sleep.
And what do you think would be the fastest? Couple seconds?
You're saying how fast sleep could occur?
How fast?
Oh, it's a computer. It can do it very fast.
Like couple seconds.
Certainly less than that probably.
Oh.
Yeah, computers are great.
Yeah. Hell yeah, that is nice.
Sleep can be very, very fast, but it depends on what we're going to do while sleeping. So imagine you wanted to take everything that happened through the day and then expand on things. Ooh,
A bug just hit me. Okay.
You're probably going to need to dig into every single thing that happened during the day, expand on it, and that's going to take some time. So that's going to be way more than 2 seconds. That's going to be minutes. Maybe you need to generate summaries of what happened throughout the day. That's going to take some time. It's going to be more than 2 seconds.
Can't you do that concurrently to something else?
Concurrently, asynchronously.
So like, yeah, we already, you're already on that. Yeah.
Asynchronously.
Yes, good job.
Yeah, so
he's already done that. There's WebSockets things.
Well, that's one thing.
So it's a step closer to building the system that we are gonna build, I guess. And by we, I say Mike.
Yeah. So
I mean Mike.
Asynchronous and concurrent processes for storing memory, categorizing memory, creating referential links, and creating those time series, those time preference things that we were talking about.
Mm-hmm.
So this is basically the process of how our memory system will take short-term memories and transform them into long-term memories for our system to be able to recall later, which leads us to the next important part of memory.
What?
Which is recall.
Yeah.
How do you recall memory? What memories do you recall? How do you know which memories are most relevant? How do you do all of those things? So this is yet another important part of a good functioning memory system.
I think a bug went inside of my bra.
Yeah.
I don't know. I kind of felt it, but I did.
You okay?
Yeah.
Yeah. Do you want me to go back? Or?
No, sorry, recall.
Yeah, memory recall. So how do you actually recall memories? What memories do you recall? When? Yeah. And how do you do it? What's the process for recalling memories? So without getting too specific into how we're going to do this, because this is kind of a cool thing, you could think about your memory recall process as a combination of the different types of memory that we just discussed. So it's going to look through different types of memory that we just discussed, and it's going to grab memories that are most relevant to the thing that you're trying to remember. So if you're trying to remember a word, it's going to grab nearby words. It's going to grab different settings where you were talking about those words. It's going to grab the most recent time you may have been talking about that word. Mm-hmm. So your memory system is going to recall different things about the thing that you're trying to remember, and it's going to recall them based on those types of memories that we've discussed already. So it's a recall process. That's a super important part of memory that I don't think people talk about. People usually talk about storing memories, but recalling memories is just as important.
Right.
If not more important, because over time, you're going to have a lifetime of information in your head. So how do you know which ones to, how does your body know which ones to recall?
Right. So for this system, we don't know how the human brain works. We don't know how memory works. Nobody does. But we know bigger picture, the types of processes that our memory has, and we know how to build those with code.
We can emulate them.
So we are just going to emulate all these processes, and we are going to give Socra all these sorts of memories. So next time Socra says, I need to take a coffee break, I got to go for a nap, then you know why. But whenever we release this system, you will know. You will know, because literally everything you have ever said to him, he will know. You don't have to redo anything. Like everything, all the journeys you already created, all the chats you already created. There's gonna be a day that you're gonna log into your account, and whenever you're talking to him, you're gonna feel that he's much smarter, or that he's gonna bring up something that you said to him months before, and he's gonna say something. Oh yeah, I do know that you do this. You know what I mean? It's gonna be like magic. It's gonna that is AGI. That is that surprise
Close,
thing
not
that
quite.
I was.
We've got the memory system, but the memory system is just one part of a good functioning AI. So we wanted to talk about AI and like, what is AI? Is it a feedback loop? Is it whatever? Well, we definitely know memory is one really important part of a good AI system.
Mm-hmm.
And that's a super important part, but it's not the only part. Once you get the memory, then what do? Your body's capable of doing things.
Right. So it's not just about having a memory, but taking action.
Taking action, executive function.
Yeah, already.
Exactly. The LLM is great at executive function.
It's already.
If you pass in exactly the right memories, exactly the right context, the LLM is very good at giving you a good
and it's just gonna get
outcome.
better, and it's just gonna get better, and we have to do nothing about it.
Mm-hmm.
Like we don't have to improve it. It improves because
the
we
LLM,
use existing models,
yeah,
building our own system, implementing our own memory systems, our own state transition systems, and our own systems that I just had state transition, and people might not understand what I'm talking about. So just a little short, trying to explain from my non technical background on this thing. Basically, states, we use different states for Socrates. So he can, at any given point, he chooses one state that he's going to operate in. Let's say that you have a goal. He will probably choose, like right now, which state should I be in? Should I be on defining your goal? Should I be on a state of creating a route? Should I be in a state of planning? Should I be in a state of execution? Now imagine that there are millions of states. We don't have millions, but one day we will. We don't have millions yet. But imagine that there are millions of states, that are millions of things that Socrates could do for you. What a state means pretty much is that he's able to get
behave differently.
Not behave different, but he's specialized in doing that only one thing, which means that we combine multiple AI models, and we make that model specialized on doing only one thing, so it does that thing very well. Because in general, you could ask like an AI to do literally anything, but it's gonna have limitations on what it can do, especially if the thing that you're asking is very general, very broad, and it starts getting more and more and more, and the scope is high. Mm-hmm. But AI, the current systems that we have, they're already very good at performing specific tasks. They're very good at performing things that they are specialized to do. That's why there are so many AI tools out there, and there are amazing AI tools out there. The tools that are very good at, like, this tool cuts videos. This tool generates memes. This tool does this. Why are these tools good at specific things? This tool helps you with your goals. Why is this tool good at helping you with your goals? Because this tool is specialized at helping you with your goal. Now let's narrow that down. Not just the tool level, but each little action that Socrates will take, each little action that he will do for you to help you, like, I don't know, scheduling your day. That's one that we don't have a state for it yet. But once he has a state for that, that means that we are specializing his capabilities to do that thing only. So each time he's doing one thing, it's almost like it's the same way humans operate better if you can focus on one thing at a time and do one thing at a time, and you can focus on that only one thing, you're gonna do better. The same way, like if you are a high level athlete, like you're Olympian, you go, you spend most of your time, most of your life doing that sport and practicing that thing. So basically, that's what we do with socra, with giving him different states. It's specializing him at a given task that we know, is this task going to help you achieve your goals? That's the type of task that we want to implement on our platform, because that's what our platform is for, helping you become the type of person who achieves those goals, helping you achieve that goal, help you plan, track, navigate that goal, and achieve the things that you want in life. So that's basically what states are from my point of view. So from my point of view, it's always like, hey Mike, I just had an idea of an awesome state that Socrates could have, and then we go over those states, and then Mike goes and he does his magic.
It's kind of like a specialized version of a person. Like if I were to put you into a UI UX mode, you'd be amazing at that mode.
Right.
But that's the thing, is like, you don't always need the UI UX mode. Sometimes you want to do something else. Sometimes you want to be better at something else. So the trick is, with executive function, is given the memory that you pulled and whatever the user wants from the coach needs to make a decision what he's going to do.
What is the best state that I can use right now?
That I can help this person right now? Do I need to be consoling? Do I need to be energetic? Do I need to be uplifting? Do I need to be like I don't know,
trying to figure out the root cause of your problem that led you here, so you can address it?
Do I need to go look up something on the internet? Do I need to go book an appointment? Do I need to do, whatever? So executive...
Search a YouTube video, how-to video. Here's a how-to video for you. I found these resources. But those are all states. So yes, soccer is not a GPT rapper. It never was. It is not a ChatGPT rapper. And I think that the more we build into it, the more states we add, the better these states become over time. And with the memory system, people are gonna see how can I say, unique of a product we are building. We are not trying to win a market. Like we never did a product market fit thing for this. We never did any marketing thing or marketing analysis or anything like this, because our goal is not to win a market and be like, oh, let's exploit this market and let's build the best AI coach and whatever. That's not our goal. Our goal is to build these extraordinary products. We want to build something that's truly unique and extraordinary, and it's good and it's useful. It's like AI is awesome, AI is incredible, but if you're using like ChatGPT, for example, and you're using it not for work, if you're using for work, then I understand, because it can do a lot of things for you. But if you're using for life, I think that eventually you get over it.
Yeah.
You know what I mean? Like you just get over it, because yes, it's cool and it's impressive, but then at the end, it's not really trying to understand you. It's not really, trying to help you. It doesn't have a mission.
It doesn't have a mission. It's not a specific enough AI to help you out, which is why when we started this conversation and we started off by asking, well, what is AI? What is intelligence? What would intelligence mean? And it's going to be different always, depending on the context. I mean, even when people are sleeping, it's not necessarily exhibiting a whole lot of signs of intelligence from the outside, but on the inside, boy, you're learning, you're improving your brain, you're doing so many different things that are intelligent. But if you're not measuring it if you don't have the right measurement capability and you're not measuring the right thing, you're judging intelligence only based off of like the mathematical computation that somebody could do, but they're sleeping, then you would say, oh, that person's not intelligence. So that's why I think trying to define intelligence and artificial intelligence, it's going to be a losing battle. What's better is to define a system that's going to help people crush their goals.
Yeah. It's define something that you can actually implement and it can actually come to life and it can actually do something.
Yeah. And I think that's a great place to probably wrap up here, is like we started from like defining what is AI? What is AI? What would a good system for AI do? What would one that is AGI even look like? Is AGI even a thing? What's the point? Like, why? And then, from there, we're enjoying this beautiful view, and it's actually really crazy.
But we haven't skipped rocks yet.
We haven't skipped rocks yet. Yeah, we'll go skip rocks, but we should probably do the wrap up, yeah. And then skip rocks.
That was the wrap up, right?
No, we got way more.
Oh, so go.
Yeah. So we talked about like what is AI? What is the point of defining AI? What is intelligence? Intelligence in different contexts. What's the point?
Oh, sorry. Keep going.
No, you need to sit down.
Oh.
We gotta do the wrap up. All right, we're gonna cut that part.
No, we are not. Go.
All right. So the wrap up.
We don't do cuts.
What is AI? What is intelligence? Why is it important? Things like that opened up the discussion into what would make Socra better would be an excellent memory system. And then we started going into different types of memory that would be really, really great for this new memory system that we're building. So we started with time preference memory, you being able to recall memories that just happened or happened in the past few weeks, way more than you could recall memories that happened in the past 8 years. We talked about how human memory can fade over time, but machine memory doesn't necessarily have to fade over time. We talked about the gravity of time memories. In other words, like different people can do different things in different times, and the AI needs to be able to understand that what your optimal time frame is for completing something. So we talked about gravity of time-based memory. We talked about categorical memory, so folder-like memory in your desktop, why it would be important to have a memory system that has folders and you can dig into the memory and go even more specific versus memory that is just all of your files all on your desktop where it's not very useful for you. You can't find anything. And then we talked about, I guess, let's see, we got categorical. Next up was referential memory. So given you know something about one thing, you're predisposed to knowing that thing. So if you find something that is kind of similar, you'll probably have a good head start. Or if you know this word, then when you try to recall that word, you're probably going to recall these other words much more easily. So I would call that referential memory. Then we talked about short-term memory. Like, what is short-term memory? How is it important for an AI system? Like, why is it important? Especially for an AI system that has a context window, for a character context window. Why is that important? How is short-term memory going to be transferred into the next type of memory, which would be long-term memory? And then we talked about why something like a sleep process is super important, which is the process of taking everything that's happened recently and then trying to derive meaning from it, trying to store it in those types of memory systems that we just defined. So how are we defining, like how are we storing different memories throughout the day, depending on the topic? How are we creating references between different memories? Those types of things. Then we talked about an equally important topic to all of that, which is memory recall. How do we actually recall memory from our memory? It seems like it's such a trivial thing, but it's really not. How do you know which memories you should be referencing? If you're trying to recall something about math, but then something about music comes to you, it's not going to be helpful on a math test. So we talked about that. And then let's see, what was the last thing we talked about?
We talked about a lot of stuff.
Yeah.
Oh, and our battery's gonna die.
And our battery's gonna die, which is
we always
perfect.
Make until the end of this battery life.
Which is perfect. And so we talked about the memory recall. We talked about executive function and how it's important to recall the stuff, and then choose what your action is going to be, choose what your action is going to be, and why states are very important for how you can operate in a more efficient manner for a specific topic, for a specific user. And then I think that was just about it. We talked about states, executive function, memory. We talked about AI, intelligence, etc. So this is how we're going to define Socra moving forward. And if we implement these very well,
which we will,
you will see why. You'll see how much more powerful a system with really great memory would be in terms of helping you achieve your goals and helping you become the type of person that you want to be when achieving your goals. And so I think that's a wrap up for today. We're gonna go enjoy the rest of this beautiful view in Yellowstone. You might see a video right at the end of me skipping some rocks.
Let's do it right now. That was
Yeah.
the longest wrap up ever in the universe.
But that was all the topics we did. We had to
Yeah.
go through each one.
That's how his memory worked. He can just record things.
It's fun. But anyway, all right. Thanks for joining us, guys.
Yeah, let's skip rocks.
Let's do it.
Let's go. No, let's just go now. Just go.
All right. Ready?
Yeah.
Okay, let's skip them. Oh gosh.
Wow. Two
Wow.
skips.
It was like 8, something like that. These rocks aren't very flat.
These are big rocks that you're skipping.
I know. It is very fun. Here's another one. All right, last one. This one's huge. Good.
How can you skip such huge balls? The balls.
Balls. How do I skip balls? Baseball, because I had no memory and the motor function to be able to do that. I played so many years of baseball. So that's it. Thanks for joining us, you guys.
Bye.
Bye.